In this example, we're going to solve the following rational equation. In this example, I want to illustrate the point that if we have a fraction that we know is equivalent to 0, then it must be that the numerator is equal to 0. So because this entire rational expression is equal to 0, this must imply that our numerator is equal to 0. So because we know that this fraction is equivalent to 0, we can actually disregard the denominator. And what we have now is a quadratic equation that we know how to solve already. So let's try factoring this one. Let's look for two values that multiply to give us negative 20 and add to give us positive 8. Those two values are 10 and negative 2. So now that we have a factored equation, we know that either x plus 10 equals to 0, which gives us a possible solution of x is equal to negative 10, or it must be that x minus 2 is equal to 0, which gives us a possible solution of x is equal to 2. So one of the things that you should get in the habit of doing with rational equations is to double check all of your answers to see if they're valid solutions. So let's look at x is equal to negative 10. If we were to go back to our original equation and substitute in x is equal to negative 10, we're going to get a 0 in the denominator. And we can't have that, that is undefined. So we're going to disregard x is equal to negative 10. We're not allowed to consider this as a possible solution to our equation. However, if we do substitute in x is equal to 2, you can check that we get 0 in the numerator and 12 in the denominator, and this is equivalent to 0. So x is equal to 2 is the only solution to our original equation.